In this video, we're going to learn how to write formulas for ionic compounds containing multivalent elements. A multivalent element, is an element, especially a metal, that can have more than one charge. That's what that multi part means, more than one charge. More than one charge. There are some elements that are called monovalent. We don't always say that word, but monovalent means they can only have one charge. For example, sodium. Sodium is always Na plus 1. There's no other sodium ions other than Na plus 1s. So this would not be multivalent. This would be an example of a monovalent element or monovalent ion. It can only form one charge. But there are some elements that are multivalent. They can form more than one charge. An example of that would be copper. Copper could be copper plus 1 or copper plus 2. So you have to have some way of distinguishing between these. For sodium plus 1, I can just call this sodium because everyone knows there's only one sodium and it's sodium plus 1. But for copper, when you have its ion, you have to distinguish between the two. And one common way to do that is simply to put Roman numerals. Copper 1. This one here would simply be copper 2. So the rules for writing formulas for ionic compounds containing multivalent elements are essentially the same as the rules for any ionic compound formula writing. It's just that you have to pay attention to which version of the ion you have. And luckily, that's given to you in the name with the Roman numeral. So we'll do a few examples. We'll start off with some simple binary ionics. So we'll do copper 2 chloride. This is a binary ionic compound. I know that because this ends in IDE. It's chlorine changed to IDE, and this is copper. So there's only really just a metal and a non-metal. And so the rules are the same. I have copper 2. I'm told that the charge of copper is plus 2 because of that 2 there. So I don't have to go to my periodic table for that. It's just told to me here. And then chloride is minus 1 from the periodic table. And now I can just do my crisscross. And I get Cu minus 1, Cl plus 2, and then drop the signs to Cu 1, Cl2. Then you can drop the 1 because you don't need it there anymore, Cu, Cl2. And that's copper 2 chloride. We'll do a similar example, except instead of copper 2 chloride, we're going to have copper 1 chloride. So notice it's nice and easy because you're told the charge of that multivalent element. So here I have copper 1 is copper plus 1. Chloride is negative 1, as we saw before. You can do your crisscross, and you'll get Cu minus 1, Cl plus 1. Then you can drop the signs, and you can also drop both 1s at the same time. We may as well speed that up a bit, and we get Cu, Cl. So this is copper 1 chloride. This is copper 2 chloride. And it's really because of the name that was given to us. There you have the Roman numerals, and it tells you the charge. So the rules are all the same. You would even have to reduce if you need to. So we'll do an example where you have to reduce. Let's do iron 3 nitride. Again, it's nice and easy because we're told the charge of iron. It's Fe3, so plus 3. Nitride is in group 15, so it's negative 3. Crisscross, and you get Fe minus 3N plus 3. Then you need to remove the charges, the signs, so Fe3N3. Notice 3 and 3 can be reduced by dividing by 3, and you get Fe1N1, but you don't need the 1s there anymore, so you simply get Fen. So you reduce just as you normally would for the binary ionic compounds or even ternary ionic compounds. Let's try one more simple example with binary, and then we'll try an example with the ternary. So let's do iron 2 phosphide. So for iron 2 phosphide, you know you have the iron 2 plus charge because it told you there. Phosphide, group 15, minus 3 charge. crisscross there, and you get Fe minus 3 P plus 2. You can remove the signs there, so you get Fe3 P2, and there's iron 2 phosphide. The rules still apply the same way for the multivalent elements, or the ternary ionic compounds with polyatomic ions. So for example, if I had copper 2 carbonate, I would do the exact same setup, except I know the charge of copper without looking at the periodic table, it's 2. So Cu plus 2, polyatomic ion in bracket, CO3 minus 2, crisscross, and I get Cu minus 2, CO3 plus 2. You can reduce the, you can remove the charges, and you get Cu2, CO3, 2. Notice the 2's can be reduced further to Cu1, CO3, 1. And since you have 1's there, you can get rid of those 1's in the bracket as well for the polyatomic to get Cu, CO3. So the only difference is that you have these Roman numerals in the names, and they're actually very helpful. They tell you what the charge of the multivalent element is, and you can use that to do your crisscross technique to find your formula. We'll do one more example together. Let's do iron 2 phosphate. So I know this is a ternary ionic compound because there's a polyatomic ion there, and it has a multivalent element in it. It has iron, but they told me the charge, it's 2. So I don't have to go hunt for it. So it's Fe plus 2. Phosphate goes in brackets, PO4. The charge for phosphate in your reference table is minus 3. Crisscross like this, and you'll get Fe minus 3, PO4 plus 2. You can get rid of the signs there. So you have Fe3, PO4, and then 2. And you can't reduce this anymore. So we simply have our iron 2 phosphate written here. And I know there's a 3 there, and you might think, oh, that's iron 3 now. No, it's still iron 2. What this tells you is that you have 3 of the iron 2's in there. That's what that means. So nothing different really with the going from name to formula for multivalent elements, other than just the fact that you have to pay attention to what the charge is of the multivalent element in the name, because you have to specify which version you're dealing with. That's not a problem with monovalent because, well, there's only one version of that ion there. Like sodium chloride, I know it's a sodium with the charge of +1 because that's all there is.